That's a big question, Campbell. But it's a good question. So I think what you're asking is how do you tell which one you're using? Okay. So probably the best thing to do is to look at them, and you have to realize that they go in order in the triangle. Because remember, we talked about how order matters when you're labeling them for congruency. It also matters on these. So, like if you're proving a side angle side congruency, you've got a side, the angle that's included between two sides, and then that other side. So you got two sides and then the angle included between them. So if you have a problem that tells you, hey, you know, this side and this angle is congruent, what else can you prove? Or how do you prove that those two triangles are congruent? Then you're going to have to look through at the diagram that you have. Let me pull up a picture so I can kind of show you one. Do you have one on your homework that you're unsure of where to start? Okay. Let me see. Okay, so when we're talking about problems kind of like these, you have a picture of two triangles, and if we just use number 4 for an example. Now, this one is telling you to use angle, angle, side, okay? So it's kind of in a little bit different order, but let's look. It tells us that DE and AB are congruent. So if we mark those, okay, and then it tells us angle A and angle D are congruent. Now, what we know about these two triangles is that we have an angle and a side that are congruent. So we have an A and an S. Well, if we think about all the postulates and theorems we have side, 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 side angle, side, hypotenuse leg, angle, angle, side, side, angle, right? So we know we have an angle and a side, so it's not going to be side, side, side. It could be hypotenuse leg, but that one involves right triangles, and this does not tell us it's a right triangle. So it's not hypotenuse leg. So it could be any of these other three, okay? So then if we were to look at it, and now this would kind of depend on the given information that you have in order to tell which one of the other ones it would be. But because we know it's an angle and then it's the side attached to it, in order for it to be side angle side, you would have to prove this side true, okay? Now, in order for it to be angle, angle side is two angles and the side not included. So it would have to be this angle that you would prove congruent to prove it with angle, angle side, okay? Or if you're doing angle, side, angle, we know that that's two angles and the side included between them. So angle, side, angle would have to be this way, where you have this angle, this side, and then that angle. Oh, sorry, I didn't see your note, Campbell. Did that explanation help? Okay, good. Do you want me to work through the example that you found? Okay, which one was it? Okay. Hold on just a second. Megan, I'll get to yours in just a second, okay? Okay, Campbell. So number 3 on the book, we're supposed to state, sorry. Is it possible to prove that the triangles are congruent? And if so, state the postulate or theorem you would use. Okay. So when we're looking at this, we have triangle ABC and triangle QRS. What we know is an angle, and a side, right? Now, it's not the side between them, so it's not angle, side, angle, okay? So that's how you're going to know it's angle, angle, side. And then when you look at these, you can see, when you look at the two triangles, B and R are congruent with each other, and A and Q are congruent with each other. And then it's both this long side that's congruent with each other. So that's going to be your angle, angle, side. It has to do with the position of them. Does that help? Okay, good. Okay, so Megan, you have 13, 18, 19, and 20 on the book. You're welcome, Campbell. Okay, so if we look at number 13, Megan, oh, it is sharing. Can you guys see that one? Okay. So if we look at number 13, we're supposed to explain how you can prove that the indicated triangles are congruent using the given postulate or theorem. Okay. So if we look at 13, it wants us to prove triangle AED is congruent to BDC using angle, side, angle. So we're looking at AED and BDC. BDC. Okay. So those two triangles, all right? So if we draw them separately, overlapping triangles are sometimes very difficult to see, especially when they are marked up as much as these triangles are. So this would be AED, and this would be BDC, okay? So we can see that these bottom parts are congruent, right? And then we can see that both of these are right angles. Angle A and B are not going to be, we don't know that they're congruent necessarily, okay? It's not marked. But we do know that these two lines are parallel, okay? So when we're looking at this, we have to prove this by angle, side, angle. So we know an angle here. We know a side here. So let's see if we can prove these angles, okay? So what we have, when we have two parallel lines, look and see if you have a transversal. In this case, here's your transversal, okay? Now, my drawing is not very straight, but this angle here and this angle here are the one that we have to prove for angle, side, angle, right? So when we have two parallel lines cut by a transversal and the angles are in corresponding locations, what do we know about that? Yep. So we know that because they're corresponding angles. That's called the corresponding angles postulate, right? See, it goes back to last chapter. So that would be how we could prove it. Because we would be able to prove that angle ADE, angle ADE is congruent to angle BCD because of the corresponding angles postulate. Does that one make sense? Okay, good. So let's see, 18, 19, and 20 now. So for these, you're supposed to say, is it possible to prove that they're congruent, that the triangles are congruent? And then if so, state the postulate or theorem that you would use. So when we look at number 18, we know that we have parallel lines, right? Well, the only thing we can determine from knowing that we have parallel lines is whether specific angles are congruent. We're not going to be able to tell if any of the sides are congruent using the fact that we have parallel lines. And nothing else in this information here tells us that any of the sides are congruent. And we know we have side, 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 angle, side, angle, angle, side, angle, and hypotenuse leg. All of those have at least a side in them. So number 18, we're not going to be able to prove congruence because we don't have enough information. You good on that one? Okay. So now for number 19, triangle TUV and triangle TWV. So TUV is this triangle, and TWV is this one, okay? So we're not concerned with any of that, right? When we look at these, I'm going to erase that just so it doesn't look messy. So when we look at these, we know that these two outside sides are congruent, right? And then we know that this is congruent because of the reflexive property. So what we do know right now is two sides, right? So when we look at this now, the ways that we can prove that have two sides are either side, 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 or side, angle, side. So what we have to do is look and see if there's a way that we can prove another angle or another side, okay? Now, what's the definition of the side postulate? Or what does it state? Okay, and then side angle side has to be the angle that's included between the two sides, right? Okay. So let's think about this. This one's it's a little bit abstract, okay? Let's look at it like we have this triangle. And then this triangle, okay? Now, we know that these two sides are congruent and that these two sides are congruent. And then this middle side here we know is congruent because of the reflexive property. So we have proven that all three sides of those two big triangles are congruent, right? Now, if we know that all three sides of the big triangles are congruent, we also know that all three angles of the big triangle are congruent, right? Or corresponding angles between the big triangles are congruent with each other, is the way I should say that. You see that? So if we know that those two triangles are congruent, then we know that these angles are congruent. So we can prove the smaller triangles are congruent by side, angle, side. Does that make sense? Okay, good. It's hard to visually mark up unless we do like a lot of different triangles to show separately. Okay, so you're good for 19? Okay, so number 20 now. We have to see if we have enough information to prove that those triangles are congruent. So let's look. We need to tell if QML is congruent to LPN. Well, we have two right triangles. That's what I automatically see there. And for right triangles, we have to know that the hypotenuse and the leg are congruent, right? So we can't use hypotenuse leg because we don't know that those hypotenuses, hypotenuse, whatever the plural of that, we don't know that those two sides are congruent. We do know that they have a congruent leg, but that's all. A leg and an angle. So it's not going to be that one. If we look at these, ignoring the fact that they're a right triangle, we still can only prove with a side and an angle. We don't know any other sides or really any other angles for that matter. There's no other notations that tell us that any of the angles are any specific measure. So that one, we're not going to be able to prove anything congruent either. Does that make sense? Okay, good. Number 21 in the book, Isabel. Oh, I guess there's not a 21 on the worksheet. So yeah, 21 in the book. 21 says, use the graph at the right and show that these angles are congruent, and then explain your reasoning for each one. Megan, you mean in 11 through 13 in the book or on the worksheet? In the book? Okay. 11, 12, and 13 in the book are yeah, you can use the same in the same manner as 14 through 17, where you would say, hold on, let's see, 14, 15. Well, so 11, 12, and 13 are a little bit different. Remember 13, we said was corresponding angles postulate. So 11 and 12 are going to have a theorem or something like that that you can refer back to, where 14 through 17, if you can prove that they're congruent, then yes, you'll say like side angle side or something like that. But if you can't prove that they're congruent, then you'll have to say something like the sides aren't corresponding sides aren't congruent or something like that. It's not necessarily a postulate that you go back to. It's why the triangle ones that we know are not true. Okay, so for 21, let me pull. Let me get a screenshot of that one. All right, 21, Isabel. First, it wants us to show that angle CAD, which is here, okay, CAD, is congruent to angle ACB. So congruent to this angle, okay? So when we look at that, anytime you see angles that are on opposite sides of a line, it should trigger your brain to think two parallel lines cut by a transversal, okay? So the way that we're going to do that is, in order to say if they're congruent or not, we need to know if these lines are parallel. Okay, so how can we prove that those two lines on that graph are parallel? Think back to your last chapter and what we would do to prove if lines are parallel. Well, the angles are alternate interior angles, but we don't know if they're congruent. So that's not going to prove the line's parallel. We're going to have to actually calculate the slopes of those two lines to see if they're parallel or not. Okay. So we can calculate slopes easily because it gives us those points, right? So the slope of BC is going to be 6 minus 5 over 6 minus 2, which is 1 over 4, okay? And then the slope down here of AD would be 2 minus 1 over 4 minus 0, which is 1 over 4. So since the slopes are the same, they are parallel lines. So that would be how you can prove that those two angles are congruent, is by stating that line BC, hold on. You would say BC is parallel to AD because they have the same slopes. Okay. Does that one make sense? Okay. So then if we look at part B, we have to show that ACD and CAB are congruent. So let's see which angles those are. ACD is going to be this angle here, right? And then CAB is going to be this angle here. So what we would have there would be needing to prove that these two lines are parallel, okay? So again, you're going to calculate the slope between these points and then your slope between these points. And if the slopes are the same, then the lines would be parallel, and that would show that those angles are congruent. So then for the last step, it wants us to show if the triangles are congruent and then explain the reasoning. So what we proved in the first two parts would have to do with these angles here, and then these angles here. And then also, we know that that side here is congruent because of the reflexive property. So if you can prove that B is congruent, or that this one, if you can prove that this is congruent, then you can show that the two triangles are congruent because of angle, side, angle. Okay? Does that make sense? Okay, good. Okay, Devin, so for number 4 through 6 on the worksheet, you have to state the third thing that you need congruent in order to prove that those two triangles are congruent to each other using the postulate or theorem that each individual problem tells you. Okay, so when we look at number 4, it tells you that DE is congruent to AB. So we mark that. And then it would tell you that angle D is congruent to angle A. So that's this angle and this angle, right? Now, it wants us to use angle side congruence, okay? Angle side. So right now what we know is a side and an angle, right? So since we know one side and one angle, what else do we have to prove to use angle side? Another side or another angle? Yeah, one more angle. So now remember that the order is important on these when you're proving that triangles are congruent. So the difference between angle side and angle side angle is the order that they are in the triangle. So if we look at this, angle side angle is an angle here, the side between another angle. The angle, two angles, and then the side that goes between them, right? Angle side is two angles and then another side that's not between them, okay? So if we know it can't look like this or else it's angle side angle, right? So we're not going to prove this angle, right? So which other angle would we need to prove is congruent? Yes. Angle C and angle F. So then you can do the same thing again with 5 and 6. If we erase our marks. For 5, we're supposed to use angle side angle. So remember, it's going to look something like this, right? So what it tells us is a side and an angle. So what else do we need to prove? Okay, so we need another angle. So let's mark those angles, that angle and that side. So FE is congruent to CB, so that's going to tell us right here. And then angle F, which is this angle, and angle C, which is this angle. So what other angle do we need to make it look like this picture here? Yep, that's it, B and E. So for number 6, again, they give us a side and an angle and want us to use side angle side, okay? So that's going to look something like this, right? Because side angle side is two sides, and the angle that's formed between them, the angle that's formed when they meet. So if we mark DF congruent to AC, and it tells us angle F and angle C, we need to prove one more angle, or sorry, one more side, because this is side angle side. So what side do we need to prove to have it look like that picture? Yep, that's exactly right. And the order on those does matter, so you do have them in the correct order. It is EF and BC. Does that make sense? Help make it clear now? Let me look at them real quick. 7 through 9. Yeah, they're going to be the same thing. So you're going to look at those things that it gives you, decide whether it's a side or an angle by how it's listed, mark it in your picture, and then look at the congruence that they want you to use. And remember that the order of those matters. And then figure out which other part you're missing.